Our topic today is perpendicular and angle bisectors. The essential question is, how can you describe a set of points equidistant from the endpoints of a segment? I should say or from the sides of an angle. We're going to prove and apply theorems about perpendicular and angle bisectors. Our key terms coming up are equidistant and locus.
I was not done.
That's your fault. When a point is the same distance from two or more objects, the point is said to be equidistant from the objects. Let's think about this. This is what? 1, 2. Yes, the third time we've used this little prefix, root word.
Equal.
And it always means equal. So if you put it together, you get equal distance. Oh, how about that, right? Like the same distance.
I did not know that.
Well, I know.
Well, now I know.
Now you know it. Okay, so make sure we get our definition for equidistant.
How many equal words do we have?
A lot in geometry. I just said this is the third one in 2 days. Yesterday we had what? Equiangular and equilateral, correct? Okay. Triangle congruence theorems can be used to prove theorems about equidistant points. And then get this down. A locus is a set of points that satisfies a given condition. So we have like a perpendicular bisector of a segment, and it can be defined as the locus of points in a plane that are equidistant from the endpoints of the segment. Sounds really weird right now, right? Definitionally, I don't even know if that's a word, but now it is. Right? It sounds strange. We're going to put it into context, and luckily for us, we use shapes to prove these particular theorems. All right. First up, you need to write down our perpendicular bisector theorem. Okay? Here's our perpendicular bisector theorem. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of this segment. I'm going to have you guys write that down, then I will explain it to you. Guys, here's what this theorem says. Remember, our perpendicular bisector is any time when lines intersect, they form a 90-degree angle, and they cut a segment into two congruent parts.
So in half?
Yeah, well, in half. And any point that is on this particular perpendicular bisector, any point on the perpendicular bisector is equidistant from points A and B. Fair enough? Okay, so if I change this and said, hey, this is a new point, point Z, you could conclude, since it is on line segment XY, or line L, and line L is a perpendicular bisector to AB, that new point, point Z, is equidistant from A and B. Okay? All right? That's all that we're talking about when we say perpendicular bisector. So, yes, I will. I will certainly do that for you. Let's look at this first example. Perpendicular and angle
Should have
bisector.
been here.
Oh, it's not his fault. The bus can't run on time.
Yeah, it is.
Cameron. It's not.
Yeah,
All right, here we go. Find each measure. We're trying to find the measure of B to C. Check it out. A to C, you know what? Let me go back.
A to C is 38.
Hold on. Because I need to make sure I talk about this one too. The converse says if a point is equidistant from the endpoints of a segment, it's on the angle bisector. Okay? Two important pieces here that you need to know. If AY is congruent to BY, then that means that XA is congruent to XB. Okay? So that's the first thing you think about. The second thing you think about, if XA is congruent to XB, then AY is congruent to BY. You see how that works out? okay? Right? It's just a bunch of congruency that you got to think about. We haven't talked about right triangles yet. Hopefully you see the right triangles involved here,
Yes.
okay?
Yes.
Alright? So, in this example, if AB is congruent to AC, that means that B to D is congruent to C to D, so the total distance of BC is
24.
what? Not 12.
So you got 12 on one side. You got 12 on one side. So you got
Total distance from B to C. 12 units from B to D, plus the 12 units from D to C.
Yeah, I can teach.
Do it.
Preach. Do it. You can talk, we know. Alright? Next, get something like this. Guys? If TW is congruent to WV, then UT is congruent to UV, or TU, okay? So these two are congruent to each other. If I have expressions that are congruent to each other, what do? To solve, set them equal to each other, right? I mean, you know what I mean? Hopefully we're getting bored with this, okay? I hope that you guys are starting to see that honestly this class is about doing the same thing over and over again, just trying to figure out how to do it, right? I mean, we're taking expressions and setting them equal to each other, or we're taking expressions and adding them together and setting them equal to 180. We've done that a lot, right? Or 60, one or two times.
How far from Montgomery?
Long walk. Alright? So, if I did all this, I'd solve my equation, I get x equals 6.5. To find the measure of t to u, I'd take 6.5 and plug it back into my expression. Okay? That's perpendicular bisectors. The next thing we have are called angle bisectors. Our angle bisector theorem. If a point is on the bisector of an angle, then it is equidistant from the sides of the angle. Get back to it. Hi. What is an angle bisector? Okay, we drew this yesterday, part of the reason we did that, right? So I could give you a refresher. Angle bisector takes, look at this, I take angle APB and I cut it in half. I cut it in half with PC, okay? That is the angle bisector here. And what this says is if PC is an angle bisector, then AC is congruent to BC. AC is congruent to BC. I got a question for y'all. If AC is congruent to BC, is triangle APC congruent to triangle BPC?
Yes. Yes.
What theorem proves it true?
The triangle theorem.
Your reflexive property helps you out. Nope. How are the triangles? What'd you say, Caitlin? What'd you say? What'd you say? Who said it? Nope.
Darwin H?
Yeah. Hypotenuse, leg. This is the hypotenuse. Here's the leg. Hypotenuse and leg. Hypotenuse and leg, two triangles are congruent to each other in right triangles. Then the two triangles are congruent. After I've proved triangle congruency, I could say, hey guys, would AP be congruent to BP? And you could say yes, because CPCTC.
CCPTC.
You have to prove triangles are congruent before you can use CPCTC.
CCPTC.
Converse of this angle bisector theorem says this: if a point in the interior of an angle is equidistant from the sides of the angle, then it is on the angle bisector. This is a fancy way of saying if AC is congruent to BC, then APC is the angle bisector of APB. I should say PC is the angle bisector of APB. Okay? Again, a lot of mumbo jumbo congruency, right? How do we apply this theorem? Okay, find the measure. If I was trying to find the measure of BC here, okay, let's see how we would do it, guys. is AC the angle bisector of BAD? How do you know? Because what? It goes through the middle, but just because it goes through the middle, look at this. Here's an angle, there's kind of in the middle. What is it that I have to have for an angle bisector to be true? Not 90. What? Yeah, right here's how I tell it's an angle bisector. That part right there. Okay? If those two angles are equal to each other, then that means that they have to serve as the angle bisector. Okay? Remember, I got to get these root words down. Bisector. Splitting something in half. Angle bisector, I'm splitting the angle in half. Okay? Right?
I can read your practice.
Good. Can you read this? What is BC going to be?
7.2.
Yeah, of course it is. It's right here, okay?
Oh, I didn't
7.2, right?
I'm focused.
Remember, if it's an angle bisector, then that means that the points on the big angle to the angle bisector have to be congruent to each other. Right? Given that, find the measure of EFH, given that EFG is 50. Well, if the big angle is 50, it would just be half of 50. Yeah. I mean, you know, we don't need Coach Young. I mean, it's just, you know, I mean, we like Coach Young, but, guys, angle bisectors do what? They bisect it. They cut an angle in half. They divide it into two equal parts. Okay?
Go there.
Y'all do this one on your own.
Give him that. Fine.
Given that the measure of WYZ is 63, XW is 5.7, ZW is 5.7, find the measure of XYZ. Working, so it's my turn to talk. You're done talking. Given that X, you got it?
I want to say, I got it on.
What you get?
You got 11.
No. Alright,
Is that not right?
WYZ. WYZ is 63.
WY.
XW is 5.7.
Do you add them?
ZW is 5.7. What is the measure of the big angle here? 126.
Oh, yes.
I thought we were trying to. Oh,
Okay, because
Phil, I thought we were
63 would be congruent to 63 over here.
You add them. You add them.
63 plus 63 would be 126.
I thought we were. It says, alright, CXW. That's why.
Believe me, I know what happened on the problem.
That's why I'm alright.
Phil, I know we do it.
Yeah.
It's all.
Alright. S is equidistant from each pair of suspension lines.
What is that?
Parachute. Parachute, son.
I didn't even see it.
Alright, what can you
Oh, it's
conclude
all-
about QS?
It's the same.
Ah, very good. Okay.
Good job.
Angle bisector?
It can be a bisector.
You just don't can.
It's just a bisector.
Hey. S is equidistant from these two. So what do we conclude about QS? It is not the angle bisector, but the perpendicular bisector.
Bisector.
Okay? Perpendicular bisector. Alright? So when would it be an angle bisector? Okay? If, let's look back at this again. Yeah. Remember, the angle bisector, okay? Angle bisectors are going to be if, in this case, these angles were 90 degrees. Okay? You got me? Alright? That's the difference between the two. Good question. We'll work that out. We're probably a week or so away from that. Alright.
Oh, gosh.
Let's do this. Let's take a 3-minute break before we get to the next part.
I mean, Phil just got that.
Hey, Phil, write an equation in point-slope form for the perpendicular bisector. Sit down. What are you doing? Of the segment with endpoints of 6, -5, and 10, 1. There's two parts to this. The perpendicular bisector of CD is perpendicular to CD at its midpoint. First thing we need to do, is find the midpoint of CD. How do we find the midpoint of CD?
Y1 minus Y2 and X
1
1 minus 6.
That's the slope, so you close. What's the midpoint, guys?
It's not on my thinking.
Yeah. Here we go. X1, X2, Y1, Y2. Take the sum, you really just take the average of your X and Y coordinates. That's 6 plus 10 divided by 2 for X, and negative 5 plus 1 divided by 2 for Y. 6 plus 10 is 16, divided by 2 is 8.
You got -2 on the next.
Negative 5 plus 1 is negative 4. Negative 4 divided by 2 is...
-2.
Alright,
Just too good.
so 8, negative 2 is our midpoint. Okay,
That's about.
don't worry about that. Then it says I gotta find a perpendicular
Bisector.
line to that. Okay? Let me teach you how to find a perpendicular line. First, find the slope of CD. How we find the slope? Rise over run. Great. Easy and fun. Alright, here we go. Hey, here is how you find the perpendicular bisector. Number 1, you find the midpoint. We just did that. Number 2, find the slope of CD. Y2 minus Y1 over X2 minus X1. Okay? Y2, which is 1 minus Y1, which is negative 5, and whenever I have 1 minus negative 5, what does that become?
Big plus, so you get 6.
There you go. 1 plus 5 over X2, which is
1.
minus X1, which is 6. And minus 6. This is 6 over 4, correct? Alright, that is the slope of CD. The perpendicular bisector is found by taking the midpoint, finding the slope, and then taking what we call the opposite reciprocal slope. Opposite reciprocal. Take 6, 4. Take the opposite of positive 6, 4. What's that going to be? Negative 6, 4. And then take the reciprocal of negative 6, 4. Negative 4, 6. Negative 4, 6 is your opposite reciprocal slope. That's how you find a perpendicular bisector. Okay?
How'd you get the negative?
We're going to do this several times today. Opposite reciprocal. Yep, some people call it the negative reciprocal. Well, there's more to it than that, but today that's probably about as far as we'll go, right? Y'all remember how to draw lines?
Yep.
So if negative 4, 6 is my slope, that means I'm going to go what?
Down 4
1, 2, 3, 4.
and over 6.
1, 2, 3, 4, 5, 6. Correct. Or if I want to do it like this, I would go
Up
how many?
4
1, 2, 3, 4.
to the left 6.
1, 2, 3, 4, 5, 6. You got it, dog. Just like that. Okay? Look how they do it. Midpoint formula, we found the midpoint of 8, negative 2. Perfect. Find the slope of the perpendicular bisector. Find your slope, which they have as, we did this too, 6, 4, correct? And then, since the slope of perpendicular lines are opposite reciprocals, the slope of the perpendicular bisector is negative 2, 3. I want you to write this part down in your notes. Since the slope of perpendicular lines are opposite reciprocals. Make sure you got that part in your notes, okay? Opposite reciprocals. Right? Because it's going to be key that you remember not just to find the slope, but find the opposite reciprocal slope. I'll make this Joe Beth proof.
I done wrote it down. I'm an overachiever.
These slopes of perpendicular lines are opposite reciprocals. Hi,
That hurt my hand.
that's it. That's all we got for today, okay? All we got for today. All right.